I've made videos about using jointers in the past, and I'll link to some of them below. But today I want to address something that I read in my comments at least weekly. Why can't a jointer be used to make a board into a perfect rectangle with 4 flat, parallel surfaces, and when looked at the end, 4 90-degree corners? Well, this comes from a misunderstanding of what a jointer is. This is a milling machine. It's not meant to dimension workpieces. Its purpose is to dress a surface, making it flat and straight, and it's often used to prepare the edges of boards that will be glued up to make wider panels. These edge joints are why we call this machine a jointer here in the US. In Europe and perhaps elsewhere, they call it a planer, after the tool that used to be used for the same purpose, the hand plane. Incidentally, this type of really long hand plane is traditionally called a jointer plane. So you can see why those two names, jointer and planer, are used interchangeably for a machine that performs the same task as the old jointer plane. Of course, an electric jointer machine, like its hand plane ancestor, can also be used to make faces of a board flat, not just the edges. And once you have a flat face, you can put that surface against a high fence, which is set at 90 degrees to the bed of your jointer, and now the edge can be milled 90 degrees to that face. Now here's where many people make their mistake. They theorize that you should be able to continue rolling the board, making each surface square to the last, and creating a rectangle, when viewed from the end, where all the faces and edges are parallel and all the corners are 90 degrees. People will argue with me about this from time to time, some even suggesting that I might be an idiot for not seeing how simple this is. But if you've done much actual woodworking, you'll find that in the workshop, theory sometimes goes out the window in the face of actual practice. There are several reasons why a jointer cannot turn this into this. I think you'll find this interesting, so let me explain. Imagine you start with something like this. This drawing represents the end view of a board, so you're looking at the end grain. The warped shape is exaggerated a bit for the sake of discussion, but each corner is at a different angle because wood moves and warps as it dries. So you might take it to your jointer, and you may start by flattening one face. Now you might use that newly flattened face as a reference surface, placing it against the jointer's fence as you straighten an edge. That edge will then be 90 degrees to your reference face, and you'll have one square corner. Everything's going well so far. So you flip the board end for end, keeping the same flat reference face against your fence, with the idea that you can now straighten the other edge and create your second 90-degree corner. And you're well on your way to your perfect rectangle. But here's where you hit your wall. How do you mill that last face so that the other two corners are also 90 degrees? You obviously can't put the same reference surface against the fence. And simply flipping the board and planing the final face isn't going to change its angle. You would have to use one of your already dressed edges as a reference against the fence so you can plane your final face 90 degrees to it. But how are you going to do that with gravity working against you? Even with a small board, it would be very difficult to hold that narrow edge against the fence so that the face is up off the bed of the jointer, presumably by pushing hard on this opposite edge, so the face can then be planed down one pass at a time and end up square with that edge. Not to mention keeping your fingers away from the cutter as you've got them on that narrow edge. It's not going to happen. But that's not the only problem. Let's say, for the sake of argument, that you did the impossible. You held that narrow edge against the fence while planing the last surface square to it. Then, looking again from the end of the board, your corners may all be square. But looking down the length of the board, it is very unlikely that the faces or even the edges will be parallel to each other. I explained why a couple years ago, but let me repeat it here for our new viewers. Because the jointer relies upon the flat table as a reference. Whatever portion of the board is touching the table will be cut. If the board is cupped or it's warped, not all of it will be touching the jointer table during the first few passes. That means some parts of the board's surface will be shaved away more than other parts until the entire surface of the board becomes as flat as the bed of the jointer. The result is likely to be a board that is slightly wedge-shaped, thinner along one edge than the other, or thicker on one end than the other. If you flip that board over, the jointer will then treat that opposite face independently of the one you just flattened. It will make it flat as well, but it cannot make the two faces parallel. This is hard for some people to wrap their head around because they imagine a jointer shaving off an even slice from each side of a board. That may technically be possible if the board is already a perfect rectangle, but jointers are rarely used with perfect stock. They're used to mill rough stock, and that's why you must use a jointer in conjunction with other machines. So you will use a jointer to flatten one face and to straighten one edge. Then you will run the board through a thickness planer to bring the second face parallel to the jointed face, and through a table saw to cut the final edge parallel to your jointed edge. That's how you get 4 flat, straight, square sides on a board: a jointer, thickness planer, table saw. At this point, some people wonder why you can't just eliminate the jointer and do all of this with your thickness planer. Buy one machine, take up less space, right? Well, technically you can, but it is a little complicated. You see, the thickness planer utilizes feed rollers to pull the workpiece through. The pressure on these rollers can force a board flat as it's being cut, and then let that cup or twist spring back when the rollers release it. Sometimes you can get a board reasonably flat by skip planing, which means taking many light passes. Works better with really thick boards. Some use sleds with wedges beneath the board at the key places so the rollers can't press it flat. There are even ways to joint the edges of a board on a table saw or a router table. So it is possible to eliminate that big jointer from the equation if you have time and patience and you're not doing a bunch of boards from a project. Let me know if you'd like to learn more of that in the comments below. But before you do, I have another tip for you. MyWoodcutters.com is the sort of small business I like to support. Stefan is a great guy, and he can find you knives and cutters for almost any joiner, planer, shaper, or molding machine. And his are the best prices if you're planning to upgrade to a helical carbide cutter head. Please use the link below this video to check with him before you buy somewhere else. Some small businesses are just worth supporting.